Okay, guys, so this is section 2.3. Section 2.3 is about lines and also about, we introduce the concept of the slope of the straight line. So first objective, it's about calculating the slope of a straight line. So the slope, most of you knows as a rise over run, which means rise means change in y divided by change in x, which means the slope, the formula of the slope is change in y, so we have y2 minus y1 divided by change in x, which is x2 minus x1, where x1, y1, and x2, y2 are two distinct points on the line. So the formula which you guys need to know, it's y2 minus y1 divided by x2 minus x1, and we need to give the condition that x2 minus x1 can't be equal 0, which means x2 cannot be equal to x1. So that's the condition, because we're giving that condition because we cannot divide by 0. Slopes, the meaning of the slope is the slope represents the steepness of the line. Steepness of the line. I hope that I spelled that correctly. So the number which you're getting from the slope, let's say 5, just tells you how steep the line is. So slope can be positive and negative. So positive slope means that your line rising up. Negative slopes mean that your line rising down. So let's start with the example. So here in the first example, I'm going to teach you how to find and interpret the slope of the line. The slope of the line given 2 points. Given 2 points. So this is the problem. So the slope m, because usually the letter for the slope is m. So let me go back to that definition, slope. So the notation of the slope, it's letter m. So the slope m of the line containing the points 1, 2 and 5, -3 may be computed as. Okay, so here what I want you to do, I want you to find the slope of the line which have 2 points. So what you're going to do, okay, So the first point, let me show the solution. So the first point, okay, is 1 comma 2. You're going to label 1 as x1 and 2 as y1, and the point 5 comma negative 3 you're going to label as x2, y2. So now what you need to do, you need to find the slope using slope formula, which is y2 minus y1 divided by x2 minus x1, and you're just plugging in. So we're having y2, which is negative 3 minus 2 divided by x2, which is 5, minus 1, and we're getting negative 5 divided by 4, and this is our slope. Okay, so that's the slope. So how are you going to interpret the meaning of the slope? Because they may ask you questions like that on the homework. So that means that for every, because don't forget that slope is a ratio, so for every 4 unit, so here I refer to this one. So for every 4 unit change in x, because again 4 will match with the change of x, so for every 4 unit change in x, y will change by negative 5 units. So y, okay, will change by negative 5 units, okay, because y, that negative 5 refer to change in y's. So that's how you interpret the meaning of the slope. What that means? That means that if x increases by 4 units, then y decreases by 5 units. So maybe that will be better for you, okay? That means if x increases by 4 units, so I'm talking about x increasing by 4 units because look, here we have positive 4, okay? From 5 minus 4, 1, we end up with 4. So by x increasing by 4 units, what's going to happen to y? Then y will decrease by 5. By 5, and again, y will decrease by 5 because again, like you see, the change of y is a negative number. Okay, so that's the meaning of the slope. So now let me give you, the next one will be the different types of slopes. So you can have a positive slope, negative slope, slope can be equal 0, or slope can be undefined. So let me give you those information. So types of slopes. Types of slopes. Just give me a second. Types of slope. Okay, so let me give you them. So we can have positive slope, positive slope. That means that the line slants upward. from left to right. Okay, so we may have positive slope, so you graph the straight line on the coordinate plane, and right here, this line has positive slope because our line slants upward from left to right. Okay, so this one, for example, this line may have a slope, let's say m equal 3. We can have negative slopes. It's going to be the opposite. That means the line slants downward from left to right. Okay, so we have coordinate plane and negative slope that can be line like this. So this line it has negative slope, for example, n equal negative 4, because this line slants downward from left to right. Okay, so positive slope, you can imagine yourself hiking, going up the hill. Negative slope, you can imagine yourself actually sliding down from the hill. Okay, and also we have 0. Slope can be equal 0. Slope is 0. And when slope is zero, that means the line is horizontal. So every single horizontal line has a slope equal 0. So this is our coordinate plane, horizontal line, let's say something like this. That's the horizontal line. Here you will know that the slope of this line is 0. Any horizontal line that has a slope 0, because slope represents the steepness of the line, this line, it's not steep at all. And slope, it's undefined. Slope is undefined. So slope is undefined. That means the line, it's vertical line. So every single vertical line has undefined slope. You cannot find the slope of vertical line. So vertical line, that's the line which goes up and down, and vertical lines, slope is undefined. M is undefined. We cannot find, because again, we cannot define the steepness of vertical line. Okay. Also, what is important, I just quickly going to mention, okay, that when you're drawing the straight lines, this is the node. Okay, so we have coordinate plane, x and y, and you may see different type of slopes. So let's say you have line like this, and then you may have a line like this, and then let's do orange. You may have a line going that way. Okay. Maybe blue. Okay. And you may have a line going that way. Okay. So we have different type of lines. So first of all, how you going to know? Like, let's talk about line, the one which is in red. So like you see the line which is in red, that line, it's pretty steep. Okay, so that means the slope, so this line right here, it's pretty steep. So that means the slope can be maybe 5. So we'll have a bigger slope. The orange line, Okay, right here, this line has definitely positive slope, but it's not so steep comparing to the line red. So here you may have a slope equal like 1/2. Okay, but it's still positive. Now the green line, okay, right here, that's going to be the line which slants down from left to right. So I know the slope will be negative. Maybe it's not so steep like the line in red, but a little less. So I would say the slope has to be negative. Maybe the slope of this line would be like -3. Okay, so still absolute value of -3 is 3. So that 3 represents how steep the line is. And the sign in front of the slope just tells you if your line goes down or rising up. The blue line, look what happened here. We'll talk about it. It's parallel, the blue one, it's parallel to the green line. So it's going to be the theorem that when two lines are parallel to each other, so that means they have to have an equal slope. So they have the same steepness, and the blue line will have the same slope like a green line, which is -3. Okay, so that was just explanation. Of course, I will give you all those theorems, but I'm not going to draw all of that. So I was trying to explain that early. Okay, so next what we're going to do, that's the objective 2. Objective 2, it's about graph lines given a point and the slope. So here I'm going to teach you how you can graph the straight line knowing the slope and one of the point. So let's do the example. Draw a graph of a line contains the point 3, comma 2 and has a slope of, and we're going to do two examples here. A, the slope is equal 3/4, and in B, slope will be equal -4/5. Okay, -4/5. Okay, so let's do solution A. Solution A. So what we know, we have a point which belongs to a straight line. This is 3, comma 2. And we know that our straight line has a positive slope. Okay, so my line will be rising up from left to right. So how are we going to draw that straight line with our equations? So have your coordinate planes. And we're going to start it with plugging in the point, which is given 3, comma 2. So we have a point 3, comma 2. Now, what we know about the slope, that the slope is positive, and also slope represents change of y over change of x, which we call rise over run. Okay, so what that means, from this point, which is given, I'm going to rise 3 units and I'm going to run 4 units. So this one, that's how it works. So we have the given point, the slope is 3/4, okay? So that means from this point, I'm going to rise 3 units, which means going up 3 units, 1, 2, 3. And I'm going to run, which means I'm going to move to the right 4 units, 1, 2, 3, 4. And that's where it's going to be my next point. And then you can continue. From this point, I'm going to rise 3 units, 1, 2, 3. And then I'm going to run 4 units, 1, 2, 3, 4. So run represents, so rise represents the change in y, run represents change in x. So when I rise, you're going up or down. Okay, like you see, your y-axis goes up and down. For run, you're going to either move to the right or to the left. So the rule is that when the numbers are positive, you're moving up and you're moving to the right. And now when I have 3 points, and of course I can do opposite. I can go actually down 3 units. So it will be 1, 2, 3. And I can move to the left 4 units. 1, 2, 3, 4. And I'm going to find more points. Okay, so you'll connect the points and we have a straight line. Okay, so let's do the same example, but B. So here also we're going to start with graphing point 3, 2 on the coordinate plane. Okay, 1. So 3, 2, 1, 2, 3, 2. Okay, right here, this is the given point. Now look what happened with this slope. This slope, it's negative. So when you have negative slope, this is what I'm doing. I'm bringing that negative to numerator. So I have negative 4 over 5. Definition of the slope is also rise over run. In this case, my rise is negative, so I will go down 4 units. And my run, which is 5, it's positive, and I will move to the right 5 units. So from the given point right here, I'm going to move 4 units down because the slope is negative. So I have 1, 2, 3, 4 units down and 5 units to the right. 1, 2, 3, 4, 5. So that's my point right here. Okay, and you can continue. Okay, as long as you keep the same ratio. So from this point, I'm going 4 units down. 1, 2, 3, 4, and 5 to the right side. 1, 2, 3, 4, 5. So I have 3 nice points, and again, I see that definitely they creating the straight line, and that also makes sense because my line has negative slope, which means should be going down from left to right. So this is how you're using slope to graph the straight line using the information rise over run. And those who took some math classes recently, you guys should remember that. So I'm moving next to finding the equation of vertical line. So that will be the objective 3, finding the equation of a vertical line So don't forget that the vertical line, that's the one which only has x. Let's say x equal a. Okay, so that's the vertical line. So also, what we know about vertical line, we also know that vertical line has a slope which is undefined. So let's do the example. Let's just review. Graph the equation x equal 3. So x equal 3, like you guys see, you don't even see y. That means this is your vertical line. X equal 3, so you're going to find 3 on the x-axis and just create the vertical line which goes through that point. So this is our vertical line x equal 3. Okay. So equation of the vertical line, that's the line which has the form x equal a. And again, just remember that the vertical lines has undefined slope, and that A here is the x-intercept. So in this case, x equal 3, 3 represents the x-intercepts right here, and then you just draw the vertical line through that x-intercept. Okay. Next, what we're going to review, we're going to talk about how to use the point slope formula of the line to identify horizontal lines. Okay. Next objective. So our objective 4 is use the point slope formula. Use the point slope formula. So that will be next objective, and also in next objective I'm going to talk about horizontal lines. Here also let me just go back to vertical lines. Sorry that I'm jumping like that. Let me just write this down, that the vertical lines, just review that again, vertical lines have undefined slope. So we have those information together. So next what I'm going to do, I'm going to teach you how to write the equation of a straight line using one point and the slope. So point slope formula, also important, you guys need to know that. Point slope form of equation of a line. So point slope form, it's y minus y1 equal m times x minus x1. Okay, so this is point slope form of the line, and let me just write this down, that where in this formula m is a slope and x1 y1 is the point on the line. So we have one given point, we have the coordinates, and slope is known. So again, we know slope, and also we know the coordinates of the point which belongs to a straight line, x1 and y1. So when you create the equation, the point slope form, m, x1, and y1 has to be substituted with given information, and your equation only keeps y and x as variables. So let me show you how to use that form, how to create the point slope form of the straight line. So let's talk about the equation. Example, I'm sorry. So we have an equation of the line with slope 4 that contains the point 1, 2 can be found by using point slope form. Okay, so point slope form. Okay, we know the slope, which is 4. We know the slope, which is 4, and we know the point and coordinates of the point, which is 1 and 2. Okay, so solution. Given information, our slope, which is 4, and we have a point 1 comma 2, which we know 1 represents x1 from the formula, 2 represents y1 from the formula. So point slope form is y minus y1 equal m times x minus x1. And we're going to substitute. We're going to replace m with 4, and we're going to replace x1 and y1 with 1 and 2. Okay, so let's do it. So we have y minus y1, which is 2, equal m, which is 4, times x minus x1, which is 1. And what happened? We already have the point slope form. This is point slope form. Many times from the point slope form, they actually want you to get to slope intercept form. So next, what you want to do, you can solve this equation for x. I'm sorry, for y. So solve this equation for y, which means add 2 to both sides. You want to isolate y, and that will give you y. It's equal 4 times x minus 1 plus 2. We're going to distribute 4. So we got getting 4x minus 4 plus 2. So we have y, it's equal 4x minus 2. So this is equivalent equation to the point slope form. This is slope intercept form. And I'm going to introduce that in a second. So I want to explain to you that the same straight line can be expressed using point slope form, which we find right here. That was point slope form. And if you're going to continue simplifying and solving for y, that will always bring you slope intercept form. And I will explain that in the second, the slope intercept form. So slope intercept form tells you that the number which stands by itself, it's the y-intercept, and the coefficient which is in front of x, it's a slope. But before we move to this one, let me also talk about the horizontal line, because this is our objective. So next example will be find the equation of the horizontal line containing point 3 comma 2. So couple things here. You guys know that we have to find the equation of the horizontal line. Okay, so horizontal line, let's just review. Horizontal line horizontal line is the line which has the form y equal b. Okay, that's it. There is no x. So just remember that. And we know the slope of horizontal line is 0. So what I'm going to do, I will try to graph it. Okay, I will try to graph it. So we have horizontal line. Okay, what we know the point is 3 comma 2. Okay. And what you know about horizontal line? Okay. So going back to this problem. So what we know, that horizontal line, so we have a point 3, 2, and also we know that horizontal line has slope equals 0. So that means from that point, you cannot do rise over run, because when you will do rise over run, you will end up at the same position. Okay, also what we know about horizontal line, that's the line which goes from left to right. So when you have that point, what you need to do, you just need to create a horizontal line which intercept that point. Okay, and also, okay, it should be right here on 2. The 2 is here. And also, since we're talking about horizontal line, here, that y equal b is the y-intercept. So in our case, okay, y-intercept will be 2, y equal 2, right here. So I have a point 3, 2 right here, and to draw the horizontal line, you just need to draw the horizontal line which goes through that point, and of course intersects the y-axis on y equal 2. That's it. We don't need to use any of the formula for that. Okay. Next, what I'm going to talk about how to find the equation of the line given 2 points. So that's the next objective. Which objective is that? 4. So that's objective 5. So let's move on to objective 5. Objective 5 is find the equation. So finding the equation of a line given 2 points. Okay, so let's do the example. So find the equation of the line given points, and we have 2, 3 and -4, 5. Graph the line. Okay, so what we have 2 points and that's it. So note for this one will be use slope point formula. Let's review that formula. Y minus y1 equal m times x minus x1. Okay, so this is the hint for that problem. You want to use Pointslope formula. So let me give you steps. So step 1, like you see in Pointslope formula, you need m, you need slope. So you're going to find the slope. Using the formula, m is equal y2 minus y1 over x2 minus x1. So we have 2 points. We have point 2, 3 and -4, 5. The first point you're going to label with x1, y1. The second point you're going to label with x2, y2. And just find the slope by substitute those coordinates into the formula. So we have y2 minus y1, so we have 5 minus 3 over x2 minus x1, which is negative 4 minus 2. And that will give you negative 2 divided by negative 6. You always reduce the fraction to the simplest form. That will give you 1 divided by negative 3, which is just negative 1 over 3. Okay, so that's our slope. Okay, so we know m. And like you see, we already can actually replace that m with negative 1 over 3. Okay, so step 2 will be use the point in any of the points. Usually I'm using the first point because I already label as x1, y1. So use the point 2, comma 3 and slope m equal negative 1 over 3 to get the point slope form of the equation of the line. Okay, so 2 comma 3, right? We already labeled that. We know that 2 is just x1, and we know that 3 is our y1. So point slope formula, let me rewrite that again. Y minus y1 equal m times x minus x1. So m, we're going to substitute with the slope, which is negative 1 over 3. x1, we're going to substitute with 2, that's the x-coordinate of the first point. y1, you're going to substitute with 3. Okay, so we're going to do the substitution. So we'll have y minus 3 equal negative 1 over 3 times x minus x1, which was 2. And look what happened. We have point slope form. Point slope form. And on the homework, when you guys will be working the same thing later on a test, you will need to read exactly how they want you to leave the equation. If they want to use point slope form or different form of the straight line. Here I'm going to use the point slope form and I'm going to graph it because the problem is asking also to graph the straight line. And to graph the straight line, we need 2 points. So 2 points are given. We have a point 2 comma 3. 2 comma 3. So we have this point, and the second point which was given was negative 4 comma 5. Negative 4 comma 5. Right here. So I have 2 points. Try to connect them. And again, I'm drafting that by hand. But like you see, this line, it's not so steep. It's sliding down from left to right. And also look what happened. We find the slope, which was negative 1 over 3. So the slope, it's the absolute value of negative 1 over 3. It's 1 over 3. 1 over 3, it's a very small slope. So that's why that line, it's not so steep. Okay. Next objective, objective 6. In objective 6, we're going to write equation of the line. It's about writing equation of the line in the slope intercept form. Slope intercept form That's the form which most of you know already. Okay, this is very popular form of the straight line. So slope intercept form of equation of a line is y equal mx plus b. That's a slope intercept form where m is a slope, so the coefficient in front of x represents slope, and b is the y-intercept. Okay, so b is the y-intercept. And that's it. So m is the slope, b is the y-intercept. So let's practice. Let's do the example. So next what we're going to do, find the slope and y-intercept of the equation 3x plus 6y equal 12. Okay, graph the equation. Okay, so let's talk about the solution. So what you need to do, you need to apply a little bit of algebra here. To be able to find the slope and y-intercept, you need to rewrite the given equation in a slope-intercept form. So step 1, rewrite 3x plus 6y equal 12 in slope-intercept form, which just means solve the equation for y. So we need to solve this equation for y. So let's isolate that y. So we subtract 3x from both sides. So we're getting 6y equal 6y equal 12 minus 3x, and then divide each by 6. So we're getting y is equal to minus and 3 over 6. You can reduce that. This is just 1 over 2x. And again, you want to rewrite this equation in a slope-intercept form, which is y is equal mx plus b. So x should be in front of the whole number. So let's just switch that. So y will be negative 1/2 x plus 2. So I just move this in front of 2. Okay. So this is slope-intercept form. Okay, and the same thing here. This is slope-intercept form. So having slope-intercept form, you know that the coefficient in front of x, it's your slope. So we know the slope is equal to negative 1/2, and y-intercept is the number which is by itself. So this is our y-intercept, positive 2. So graphing the straight line, you already know y-intercept, which you already have 1 point. Y-intercept is 2. So we already have a point on the y-axis. We know slope is equal to negative 1/2. which means rise over run, right? That's the slope. So that means we will go down because it's negative 1 unit, and 2 it's positive, and we'll move 2 units to the right. So from this point, I'm going rise over run, so I'm going down 1 unit and 2 units to the right. 1, 2. So that will be my second point. And you can find more points if you want it. You will go down 1 unit and 2 to the right. 1, 2. So I have 3 points. You can connect them. And that's the equation of our straight line. Okay. And if you have a graph paper, you can easily see that the coordinate of this point is 2, 1, and coordinate of this point is 4, 0. Okay. So if you graph it on the graph paper. So this is slope-intercept form. Usually we leave the solution in slope-intercept form. We like to use slope-intercept form for graphing because it's very fast graphing. But there's also one more form of the straight line. So let me give you the next objective. There's many objectives here. I think this is objective 6 or 7. That was 5, so this is objective 7. Yeah. Objective 7. I hope you guys taking your own notes because when the lecture is long, for some reason my OneNote, when it's too long, don't save all the information. So this is objective 7. Objective 7 is about general form of the straight line.